Okay, so now we're going to add and subtract integers. So you need to realize what integers are. They are positive and negative whole numbers, and that also includes 0. So the positive numbers on a number line are, of course, on the right. The negative numbers are to the left of 0, and 0, of course, is always in the middle. And 0 is neither positive or negative. All right, so on this page, we are going to order, and by the word order, I mean that we're going to decide which one is bigger or which one's smaller, whichever way you want to look at that. And we're going to use less than. This is your less than. This is your greater than. Okay, and so you put the fat part facing, or the open side facing the bigger number. So 14 is greater than 6. Now, on part B, you have a -1 and a +9. And positive numbers are always bigger than your negative numbers. So you would read that as -1 is less than 9. Okay, so with part C, you got to be a little bit careful here. Think about in terms of your checking account. Which one would you rather be overdrawn if you had to be? I would rather be $1 overdrawn, so that is greater than -4. And again, on part D, positive numbers are always bigger than negative numbers. If I ever ask you for the opposite of a number, then I am asking you for if it's positive, it's going to become negative, but stay the same number. If it's negative, it's going to become positive, but stay the same number. So opposite notation means just whenever you put a negative sign in front of that number. So it can be read as the opposite of A. You could say -A, that's fine, but just so you understand, it means the opposite of whatever A means. Okay, on part A, we're going to find the opposite of 7. The opposite of 7 is -7. On part B, the opposite of -10 is +10. And on part C, I've got the opposite of -6. And what is the opposite of -6? It's +6. The whole numbers and their opposites are called integers. All right, so we're going to evaluate the opposite of x when x is 8. So what is the opposite of 8? It's -8. So this says the opposite of x when x is -8. So it's going to be +8. And just so you know, it would look something like this. So I've already got this one negative sign there, plus I'm going to have another one. So I've got this and this, which would give you a +8. All right, so the absolute value of a number is the distance that the number is from 0 on the number line. And we use vertical bars called absolute value bars. So if I want to know the absolute value of 5, that distance is 5 units from 0. If I want to know the absolute value of -5, that distance is also 5 units away from 0. All right, so on part A, we're looking for the absolute value of 3. How far is 3 from 0? It's just 3 units away. On part B, how far is -44 from 0? It's just 44 units away. And on part C, how far is 0 away from 0? It's 0 units away. Okay, so with this page, the first thing that I usually do is I write down the two numbers that I'm comparing. So on part A, the absolute value of -5 is 5. On part B, or I'm sorry, still on part A, I am looking at this right here, and the absolute value of -5 is +5. However, I've got this negative sign on the outside. So I've got a negative times a positive, which is a negative, so I'm comparing 5 and -5. So that answer would be greater than there. All right, so let's look at part B. I'm comparing 8 to, now look at this, I've got negative 8, the absolute value of negative 8, which is positive 8. However, I got to multiply it times this negative sign on the outside. So I'm left with negative 8 there as well. So positive 8 is greater than negative 8. Okay, so let's look at part C. I've got negative 9. There's no bars there or anything, so I'm just comparing negative 9 on that side. On the right side, I've got a absolute value of negative 9, which is positive 9, times the negative, which is negative 9. Those guys are equal to each other. Okay, so let's look at part D. Notice this is a parenthesis, not an absolute value bar. So I've got negative times a negative, which is a positive 16. And on the right side, notice how I've got negative 16 on the inside of the absolute value bar, so that's going to be a positive 16 times a negative on the outside, so I'm left with negative 16. All right, so we're adding to our list of grouping symbols. We used to only have 3, now we have 4. We're adding the absolute values to that. So absolute value bars are considered grouping symbols. Whenever you're following the order of operations, you've got to do what's inside the absolute value bars first. Okay, so let's take a look at this. So I've got absolute value bars, plus I have parentheses. You always want to do the innermost grouping symbols first, so the first thing I want to do is that. So I'm just rewriting everything else. And instead of 6 minus 2, I'm going to put 4 there. Now again, I want to follow my order of operations on the inside of this, so I want to multiply 3 times 4. I'm rewriting everything else. Now I want to do 19 minus 12 because it's still inside the absolute value grouping symbols. Now I want to take the actual absolute value of 7, which is just 7. Oops, sorry. And now I can just subtract the 24 minus 7, and I get 17. I do want to warn you, your calculator does not have absolute value bars on it. It is not an operation that your calculator can perform if you're using the TI-30X2S. If you're using a graphing calculator, for one thing, you shouldn't be using a graphing calculator in this class. But if you have one of those, you will see that there are absolute value symbols. Maybe not the symbols so much, but they do have a function where you can take the absolute value of something. I am not going to teach you about graphing calculators in this class. Sticking with the absolute values, we're now going to evaluate whenever we have absolute values. So in part A, we're going to evaluate the absolute value of x when x equals negative 35. So I want to take the absolute value of negative 35, which is just 35. Now, on part B, notice how you have a negative sign in here, but you also have a negative number. This would look like this. So you would do negative times a negative, and you would get the absolute value of negative 20. Sorry, positive 20, there we go. And the absolute value of positive 20 is 20. All right, part C and D. Notice how you have negative signs on the outside of the absolute value bars. It's going to be the only time that you're going to see a negative answer with one of these problems. So on part C, you've got take the absolute value of 12, which is just 12, and multiply it times the negative. So you will get an answer of negative 12. Part D. Absolute value of negative 14 is positive 14. Positive 14 times this negative on the outside is negative, so you would get a negative 14 here. All right, so now we're going to add some integers. And again, you might want to get used to typing these into your calculator. Now I know you don't need to type in 1 plus 4 on your calculator, but I do want you to practice with the negative button. And that negative button is not the same as the minus button. The calculator does not realize that they really do mean the same thing. So you have to use the negative button that is right by the decimal. If you're typing in, let's say, part B. Part 1, you wouldn't have to type that in, but 1 plus 4, 5. Now, on part B, -1 plus -4, signs are the same, add the numbers together and keep that sign. So that means I owe somebody $1 plus I owe somebody $4. So now I owe a total of $5. All right, so whenever you're adding numbers that the signs are different, you subtract the smaller number from the larger number, keep the sign of the larger number. So on -1 plus 5, I'm going to subtract 1 from 5 and I get 4. And because 5 is a bigger number than -1, or 5 is bigger than 1, I'm going to keep the sign of the 5. So it's going to be a positive 4. You can also think of that as owing money. I owe $1, but I have $5. Whenever I give somebody the $1 that I owe them, I'm down to $4. Part B, 1 plus -5. I'm going to take the smaller number from the larger and I get 4, but because 5 is a bigger number than 1, I keep the sign of that number. Okay, so take a look at part A here, 19 plus -47. So when signs are different, you subtract the numbers and you keep the sign of the number that is bigger. So because 47 is a bigger number than 19, I know my answer will be negative. Now off to the side, I'm going to do 47 minus 19. So my answer is -28. Okay, so look at part B. The signs are the same and I'm adding, so I just add those numbers together and I keep that sign. There we go. All right, so on this page, again, we need to follow order of operations, always. There will never be a time that I say, you don't have to follow order of operations. Never. You always follow order of operations. So we're going to do what's inside these parentheses first. So I've got -5 plus 3 times -2 plus 7 is 5, positive 5. According to order of operations, I have to do this next. So I've got -5 plus 15. Now, because those signs are different, I subtract the smaller from the larger, keep the sign of the larger number. Okay, so subtraction is a little bit different. I don't want you to change what you were taught in first grade. 7 minus 5 is 2. It always has been 2. It always will be 2. So your answer there is 2. But I do want to show you a different way just so you understand what's going on whenever we have bigger numbers. So if you have 7 minus 5, you are allowed to do something called change. You're allowed to change this sign into a plus. However, in order to do that, you have to change the sign of the number immediately following. So 7 minus 5 is the same thing as 7 plus -5. All right, that's going to come in handy whenever we see these double negatives right here. So whenever you see those double negatives, you need to do change. So now we're left with -7 plus 5, which is -2. If you're typing part B into the calculator, you have to use negative in front of the 7. You have to do the minus sign, and then if you do parentheses, you have to do -5. This is the only one that should be a minus on your calculator. This guy and this guy need to be negatives. Another way to look at a subtraction problem is to consider that sign in front of that number to be the sign of the number. So in this one, I could say -3 and I could say -1, and whenever I combine a -3 and a -1, I get a -4. Otherwise, you could do this, change, You see that signs are the same, add the numbers together, keep that sign. On this one, change, change. I always get rid of my double negatives. I always do a plus plus there so that I don't make a mistake on the sign of the number. So this part B would be 3 plus 1, which is positive 4. Okay, so on this page they're just showing you that 13 minus 8 is the same thing as 13 plus negative 8. 13 minus 8 is 5. 13 plus negative 8 is also 5. So those are just two different ways to write the exact same problem. Same thing with down here on part B. Negative 17 minus 9, which is negative 26, is the same thing as negative 17 plus negative 9, which is negative 26. Okay, this page they're kind of doing the same thing to you. They're just showing you that 9 minus negative 15, so you do change, change, is the same as 9 plus 15. You would get 24 there, you get 24 there. Part B, again, change, change, so that's negative 7 plus 4, which is negative 3, is the same thing as negative 7 plus 4, which is negative 3. Alrighty, last page. So this one, again, follow order of operations, do what's inside the parentheses first, so you would have 7 minus negative 4 minus 3, you could do change, change, which is negative 7 minus 9. Now this says 7 minus negative 7. We're going to do this from left to right. So 7 plus 7 is 14. And 14 minus 9 is 5. All right, so that's it for this lesson. If you have any questions, please let me know.